This video is all about the replication cycle or the life cycle of bacteriophage, which are viruses that infect bacteria. Remember, we're using the term life cycle. Don't let it mislead you. Remember, viruses are not alive, okay? But we refer to life cycle as where we're starting with one bacteriophage infecting a bacterial cell, and once it's gone through this process, there will be many bacteriophage that exit the cell and can go on and infect new hosts. Okay, so there are two different life cycles for bacteriophage. Lytic cycle, in which case the phage kind of gets in and gets out. It infects the host cell, makes new bacteriophage, and then exits the cell via lysis, which is all right. The other life cycle is called the lysogenic cycle. And this is where the bacteriophage will get into the host cell, and then it kind of chills for a bit. It hangs out inside the host until times get stressful for the host. And then when it senses that, ooh, this is kind of a stressful environment, I don't really want to be here, then it will enter into the lytic cycle. Okay. So we're going to come back to this this figure here to see how these two life cycles are related to one another. But for now, let's go ahead and get started with the first type of life cycle. So some bacteriophages, we put T-even. That's because their name is like T4. So it's the letter T and then an even number. And these bacteriophages go through the lytic cycle, only the lytic cycle. And so there are 5 steps shown here. You want to know the names and the process of what happens at each step. And with the lytic cycle, the bacteriophage is going to attach to the host cell. It's going to use those spider-like tail fibers to attach to the host. And then it is going to inject its viral DNA into the host cell in a process called penetration. Okay, so look at the capsid here. All right, notice on the far left, okay, where I'm kind of tracing, that's the viral DNA. Okay, and notice in the second step, the capsid is empty, right? That's because the viral DNA was injected into the host cell. And oftentimes what happens that's not showed here is the viral DNA codes for things that will destroy or chop up the host DNA to eliminate competition, right? Because the virus wants to take over the host cell. And so by eliminating the host's genetic material, there's nothing for the virus to compete with in terms of resources. So sometimes the host DNA does get degraded once the viral DNA is inside. Each have genetic material. And this is also where all the phage proteins, so the capsid, the sheath, those tail fibers, all the individual components are produced inside the host cell. During step 4, which is called Okay, Zoom just kicked me out again. Let me see. I hope you all can still see this and you can still hear me. We're going to keep on trucking as though you can. All right, so what I was just doing, because I'm not sure when Zoom disconnected, I only get notified when I get reconnected, is I was re-sketching kind of what happens in the biosynthesis phase, because in this picture, it kind of looks like the entire bacteriophage is like mass produced, but really the individual pieces are what are made. So I was trying to draw up here the little capsid head, these kind of weird spider-looking things. Those are the little tail fibers, and then these random lines are the sheaths. And so then during maturation is when the individual pieces come together to form the virus. And then there's also the genetic material in there. Okay, so I just wanted you to know that during biosynthesis, the individual components are made, but they're not always completely attached like you see here. All right, and so then once the virus has spontaneously assembled into mature viruses, then they exit the cell via lysis. All right, give me 1 second here. I wanted to pause the recording if I could. My dog is going bonkers, so let's see if I can. We'll deal with it. Okay. So the other bacteriophage life cycle is the lysogenic life cycle. And so it starts and ends similarly to the lytic cycle, but it has these intermediate steps, okay? So if you follow along with this picture, it starts over here where the bacteriophage is going to attach and then penetrate the host cell. But rather than degrading the host DNA, it is going to incorporate its viral DNA into the host DNA. And we refer to this as a prophage, okay? And so the host cell does not know that anything crazy is going on, okay? So the cell proceeds like normal. It undergoes binary fission or cell division. And as the host DNA is copied, so is the prophage, okay? So the prophage is going to be replicated along with the host's DNA, and therefore the viral DNA is also passed to all the daughter cells that are made during cell division. And when this is going on, sometimes viral genes get translated into proteins, okay, by the host cell. And sometimes viruses code for dangerous things like toxins, which now the bacterial cell has in its arsenal, right? And so sometimes bacteria become pathogenic because they have this viral DNA in it. And so, this happens with things, organisms like Corynebacterium diphtheriae, which cause diphtheria. And the bacteria contains viral prophages that actually allow Corynebacterium to become pathogenic because it has the toxin, the diphtheria toxin comes from the virus. So pretty interesting. So again, the viral DNA is integrated and hanging out with the host DNA, and it stays this way until the host gets stressed for whatever reason. Maybe there's too many cells and not enough space or not enough nutrients. But either way, the host cell is getting stressed out, which is not a conducive environment for the virus. And so it excises itself from the bacterial chromosome and it enters into the lytic phase. So as you can tell on that next picture, once the viral DNA has been removed from the bacterial chromosome, it enters the biosynthesis step. So again, it's making more copies of the viral DNA, it's making more capsids, more sheaths, more tail fibers, and then they're going to mature via spontaneous assembly. And then once they're all fully made, they're intact, they're infectious, they are going to release by a process called lysis. Okay, so let's go back to that first picture real quick and let's walk through it. So if we start with the lytic cycle here on the left, okay, watch the numbering here, y'all. So again, with the lytic cycle, okay, so the phage attaches to the host cell, injects its DNA. With the lytic cycle, the phage is going to go ahead and start copying its DNA, make all the individual components needed to create intact infectious bacteriophage. It's going to go through biosynthesis and maturation. And then once they're all done and ready, they are going to exit the cell via lysis. All those newly made bacteriophage will then go out into the environment and infect their own hosts. Okay. But now let's walk through lysogenic bacteriophage. Quick little summary. So again, they start the same way. Okay, so it starts with the bacteriophage attaching and injecting its DNA into the host. Okay, but then instead of degrading the host cell DNA, the lysogenic bacteriophage is going to insert the viral DNA into the host cell. We call that a prophage. And then the cell is going to proceed as normal, and it's going to undergo cell division, which is called binary fission, make more bacteria, all of which are harboring that viral DNA. Remember, this gives some bacteria an advantage depending on what's in that viral DNA. When the host cell gets stressed out, the viral DNA is removed from the host cell DNA, and then it enters back into this lytic pathway. Okay, it goes into biosynthesis where it copies the viral DNA, it makes all the protein components, and then the new viruses are going to mature, aka self-assemble. And then once they're all intact, ready to go, they are going to exit the cell via lysis. And again, all the new bacteriophage are going to infect their own hosts out in the environment. Okay, so remember, these lysogenic bacteria also go through the lytic process. They just kind of have this integrate and chill component when they create the prophage and allow the cells to divide. Okay, all right, y'all. Let me know if you have any questions. Oh, really give yourself time to digest this material. Make sure you can list, sketch, describe each step of the lytic and lysogenic pathways. Make sure you can compare and contrast the pathways and really be able to explain them. Okay, so by the time you take your test, you want to be able to walk up to, a family member, a friend, a pet, a table, whatever it is, and teach this material to them. Okay. All right. Let me know how I can help. Bye, y'all.